The system of linear equations has a unique solution. Find the solution. X minus 2y plus z equals 1, negative y plus 2z equals 5, x plus y plus 3z equals 8. In this system of equations, there are three equations. We can regard these equations as rows. We can perform a series of row operations to obtain the lower triangular form. The rows operation we can perform are: we can multiply any row by a non-zero constant. We can interchange the position of any two rows. We can take row 2 to row 3 and vice versa. We can also multiply one row by a non-zero constant and add it to another row to replace the existing rows. Now, in this case, for the second equation or the second row, we already have y or negative y as the leading term, so we would leave it alone. We will try to eliminate x in the third equation or in the third row. And to do that, remember that we allow to multiply any row by a non-zero. In this case, we'll take row 1 and we multiply negative 1 and we add to row 3. If we multiply the first row by negative 1, then we would obtain negative x plus 2y minus z equals negative 1. And if we take this and add the third row to this, which is x plus y plus 3z equals 8, we will get a new row to replace row 3 with its new equation. This is x minus 2y plus z equals 1, negative y plus 2z equals 5, and if we perform this operation, we will get 0x plus 3y plus 2z equals 7. We then perform similar row operation to get rid of 3y in the third equation by taking the third equation, which is row 3, and add 3 times row 2. If we take 3 and multiply row 2, we will get negative 3y plus 6z equals 15. This is row 2 times 3, every single term, multiply 3. And then we add it to the third row, which is 3y plus 2z equals 7. Performing this row operation, we obtain an equation, and we will replace this new equation by the third equation. So an equivalent system of equation is now x minus 2y plus z equals 1, negative y plus 2z equals 5, and then 0y plus 8z equals 22. From this, we can perform a back substitution. With a third equation or third row, we get z equal 22 over 8, which is 11 over 4. And then we perform another back substitution where the second equation, the second row, states that negative y plus 2z equals 5. But z is 11 over 4. So this is negative y plus 11 over 2 equals 5. Y equals 11 over 2 minus 5, which is 1 over 2. The third equation gives us z, the second equation gives us y, and the first equation, x minus 2y plus z equals 1, should give us x, where y is 1/2 and z is 11 over 4. Simplifying this, we have x minus 1 plus 11 over 4 equals 1. So x equals 1 plus 1 minus 11 over 4. This is 2 minus 11 over 4, or 8 over 4 minus 11 over 4, which is negative 3 over 4. The solution to the system of equation is therefore x equals negative 3 over 4, y equals positive 1/2, and z equals 11 over 4. This is an ordered triplet with x, y, z.